Okay, so now we want to go into Archimedes' principle, and I promise you, you know a lot of this already. For example, if you have kids, or you will have kids, you will eventually tell your kids to go to the tub and fill it up and then get in. So they're going to fill the tub up with water, and then they're going to get in, and what's going to happen? Well, they're going to get in, and the water is going to overflow. And so Archimedes actually used this concept to be able to help figure out if a crown that he was given was pure gold by using density and by using pressure. So the Archimedes principle is the following. Okay, so by buoyant force, so if you hop in the tub, there are forces acting on you. You're going to have a buoyant force from the fluid pushing up, and then you're going to have your weight. So this buoyant force is B. So this is that upward force of a fluid pushing you up. You're like, well, the fluids are pushing in all directions, but the dominating force is going to be upward. The left and right forces are going to end up canceling each other out because you're not moving. So what this is saying is that the buoyant force equals the weight of displaced water. So if you catch this water that you displace, or your kids displace, that's this. So the weight of displaced water is equal to the buoyant force. Well, there's another version, another way to look at buoyant force, and that is using Newton's laws. So we know that we're not moving, so we're balanced in the tub. So that means our B force going up is equal to the weight, your weight, going down. So remember we did our free body diagram. You have B going up, you have your weight going down. So we know that both of those are equal to each other. And then from chemistry, or maybe physics, let's say that you were given an irregular shape, and I asked you to find your volume of that irregular shaped object. Well, you use volume displacement. So you would put in a graduated cylinder, you would have the original height, then you put the object in, and the water would go up, and this volume here is equal to the volume of the object. So we know, if we think about this whole concept then, so if you get into the tub, so your volume is equal to the volume of displaced fluid. So one of the ways we want to look at this and why it's going to be significant is looking at these three principles. So let's look at the first one. The buoyant force is equal to the weight of displaced fluid. And we know the buoyant force is also equal to your weight. So B equals B, so that means your weight is equal to the weight of displaced fluid. A lot of times we're trying to find volume, so this would be mass of U times gravity equals mass of displaced fluid times gravity. Those G's cancel out. And then we finally get to use density. So density is equal to mass over volume, or mass is equal to density times volume. So here's really kind of the equation that focuses on Archimedes' principle. The density of U times your volume is equal to the density of the fluid times the volume of displaced fluid. And one more step and we're going to have it really focused. So now we want to look at this green part. Oh, and this should be the submerged part. Sorry, I didn't finish this. U that's submerged, okay? So if you were all submerged. So if we're looking at this, then I can rewrite it like this. Your density your total volume is equal to density times the fluid times your submerged volume. Okay, so, and I know I'm not really doing any math because the math can get kind of confusing, especially when you only got a week to do this entire module, or in the summer you only have a day to do this entire module. So everything's going so fast, we'll not get into the mathematics, but I want you to see the applications of Archimedes' principle. We can take the fact that the buoyant force is equal to the weight of displaced fluid, and then go back to Newton's laws and go back to some chemistry that we know, and then we can actually go back and be able to compare the densities and the volumes. Depending on what's being asked, you may want to use this, you may want to use this, you may want to use this. There's so many things that's mathematically depending on the context of the problem and what you want to use, but I want you to see kind of some of the applications that are being done here. So it's a pretty neat phenomenon and a great concept. The mathematics gets a little crazy, but just kind of keep in mind that I'm not going to ask you any major mathematics, but you need to understand the concepts. You need to understand the black writing, the blue writing, and the green writing, and then you will be good to go. Okay? So in the next videos, I'm going to upload some videos that help you with Archimedes' principle, and then we'll get into pressure inside of a closed system.